Welcome to Diagramatic virtual learning platform. This is a platform that I endeavor to use PowerPoint animations to break down difficult mathematical concepts to students. I know you find this useful and you will share and subscribe for future lessons that I will post. I will begin by talking to you about completing the square. And I've divided the lesson into 3 parts. In this first lesson, I will be using diagrams to explain to you the concept of completing the square. Then I will take you through the steps to complete the square for quadratic expressions where the coefficient of x squared is equal to 1. Then finally, we'll talk about using completing the square to find the minimum point of quadratic function. Now, let's see how do we use diagrams to explain completing the square. On the screen, you have 1 centimeter square grade, and the expressions that I have is x squared plus 4x plus 4. This is 1 square unit, and I need 4 of those to represent the 4, the constant 4. So that's my 4 units. Then I need area to represent 4x. That is 1 cm, and that is x, so the area of this bar is x. And I need 4 of those, of the bar. So I have my 4 x's. So we have 4 units and 4x. Finally, I'm going to create a dimension x by x to form my x squared. Now I've got areas to represent the different 3 terms in the expression x squared, 4x, and constant 4. I'm going to rearrange all these 3 terms to form a bigger square. Now you realize that the area representing the second term, I split that into 2 and I use it to create a dimension around x squared. Now the constant is what I use to fill in the gap. So you can see I form a bigger square. Now let's look at the dimension of the bigger square. The dimension of each side is x plus 2 because we have the x dimension plus the 2 units. So that's x plus 2. This side is also x plus 2. So in terms of the area of the bigger square, it's simply x plus 2 all squared. That is the area of the bigger square. So to complete the square for x squared plus 4x plus 4, that will give you x plus 2 all squared. So that's the concept of completing the square using diagrams. And let's remind you again that I always split the middle term into 2 and I use it to form a dimension of the bigger square. So you could say half of 4 is 2. That's why it's x plus 2 on this side. That's x plus 2 on that side. Let's look at another situation and see what happens. We have x squared plus 4x plus 2. So I need my 2 units. I need my 4x. I need my x by x dimension for x squared. Let's rearrange the square now. So split the middle term into 2. Rearrange around the x squared to form the dimension of the bigger square. Now to fill in, you realize that I've not been able to complete the square because there are 2 smaller squares missing, but I can still work out the area of this shape. And to work out the area, let's look at the dimension. The dimension of this side is x plus 2. The other side is also x plus 2. So to work out the area of this shape that I've created, I just need to work out the area of the full complete square. Then I take away the 2 units that is missing. So the area of the tile or this shape that I've created is simply x plus 2 squared minus the 2 units that is missing. So to complete the square, we realize that I always divide the middle term by 2 and spread it around the x to create the dimension of my bigger square I'm trying to create. And that is the concept that we're going to translate from diagrams into algebra. So, completing the square for x squared plus 4x plus 2 equals x plus 2 all squared minus 2. Now let's go through the diagrammatic algebraic approach to completing the square. Like I said before, we are beginning learning how to complete the square for quadratics where the coefficient of x squared is equal to 1. In doing that, we always concentrate on the very first 2 terms. So the first 2 terms could be rewritten as x plus b over 2 all squared minus b over 2 squared, then plus the constant c. And if you recall the diagram, we always divide the middle term by 2. That's why we have b divided by 2. So this section measures the dimension of our square. And from this section all the way, including the c, or the constant, measures the smaller unit squares that we might need to add or take away. So this is in 2 parts. This is the dimension of the square, and this is the units of smaller squares that we need to use to fill in the gap or that will be missing. So let's see what happens with a typical example. First, you need to understand signs are very important in completing the square. This side is always negative in the formula, always. But this side could be positive if the question is given to you as a positive, and could be negative if the question is given to you as negative. So let's look at a typical example. X squared plus 4x plus 9. We first need to find out our b. And our b in this case is 4. 4 divided by 2 will give you 2. So we need to replace b over 2 here with 2 and just work it out. So 4 over 2 is 2. Replacing the formula, this is what we have. Then plus our constant 9 is what we have here. You need to evaluate what 2 square will be, which is 4. So next step, we have minus 4 plus 9. The only thing we need to do is to work out negative 4 plus 9. We now have our completing the square as x plus 2 all squared plus 5. So that means the dimension of the square will be x plus 2 on one side and x plus 2 on the other side. And we'll fill in with 5 smaller units. If you're going to use diagrams, this is what it's going to look like. This is the dimension of our square, x plus 2 on both sides. That's why x plus 2 is all squared. Then plus 5 little squares to complete the square. Let's look at the second example. Here, remember, it's a minus in the question, so our sign here should be minus throughout. B is 10, or you want to take it at negative 10. Divide by 2, you get negative 5. So you put the 5 in place of b over 2, and you're going to have x minus 5 all squared minus 5 squared plus 6. Next, let's compute what 5 squared is. Then we compute negative 25 plus 6, and that completes the square. So this also tells us that our square dimension is x minus 5 on both sides, but the square is not entirely completed because it's going to miss 19 smaller unit squares. That's why we have the expression x minus 5 squared minus 19. There will be 19 smaller squares missing if we use diagram to explain that. Exam question. We follow the same principle. B is 6. 6 divided by 2 is 3. That's why you see 3 in the formula. Compute what 3 squared is. So you have it. Then you compute negative 9 minus 4. And that completes the square. Now, we're supposed to state the values of A and B. Now, let's check if our final answer conforms to our requirement. Yes, x plus A, x plus 3 conforms that. Or squared plus B minus 13 conforms that. So to work out the values, you can see straight away that A equals 3. But B equals negative 13. B is negative 13. So that's our values for A and B. Let's look at the second one. These two questions are the same. They mean the same. That means rewrite this in the form of that, the same as this question. Our B is 8, so we divide 8 by 2, we have 4. So you're going to have 4 in the formula. And don't forget, in the bracket, this must be negative throughout. We compute negative 4 squared, negative 16. Then we compute negative 16 plus 13 to complete the square. X minus 4 all squared minus 3 is completing the square. So to state the values of A and B, you can see that A is simply 4 and B is simply 3. This time it's not negative 3 because in the requirement it says minus B. So our B is 3 and A is 4. So that's an exam question, how to answer completing the square. Now let's look at situations where we have the B as an odd number such that you can't just divide it by 2 and get a whole number. And it's not advisable to use decimals in completing the square. So we're going to learn how do we maintain the fraction in the steps to completing the square. So first, recall the formula. It's b x plus b over 2 all squared minus b over 2 squared plus c. B is 5. 5 divided by 2 is a fraction. 5 divided by 2. Slot that into the formula. That's what you have. Next step, compute 5 over 2 squared. 5 squared is 25. 4 squared, 2 squared is 4. So we have x plus 5 over 2 all squared minus 25 over 4 plus 3. We now need to compute negative 25 over 4 plus 3. You need to be good at your fractions, because if you're not good at working out fractions, you're going to struggle with this kind of completing the square. So work it out separately, and when you work it out, you should get negative 13 over 4. So in place of negative 25 over 4 plus 3, we replace that with negative 13 over 4. And that completes the square for x squared plus 5x plus 3. Done. Let's look at the second example. B is 3, so if we divide it by 2, we have 3 over 2. Like I said, maintain the fraction. Do not use decimals. So we slot 3 over 2 in the formula. That's what we have. You should now be conversant with the formula and how to substitute b over 2. Next is 3 over 2 squared. Compute that. That gives you 9 over 4. So negative 9 over 4 minus 5. Work it separately. That gives you negative 29 over 4. So replace negative 9 over 4 minus 5 with negative 29 over 4 to complete the square. So you're going to have x plus 5 over 2 all squared minus 29 over 4. Exam style question. B is 3, so 3 divided by 2 is 3 divided by 2 as a fraction. Compute 3 over 2 all squared. You have 9 over 4. Now compute negative 9 over 4 plus 7. Negative 9 over 4 plus 7 will give you positive 9 over 4. So you're going to replace negative 9 over 4 plus 7 with plus 19 over 4. And that completes the square. Let's look at the second example. If we're supposed to work out the values of a and b, as you can see, a is 5 over 2 and b is 19 over 4. Let's look at the second one. B is 7, or divided by 2, so you're going to have minus 7 over 2 in our first bracket, and minus 7 over 2 all squared. So we have x minus 7 over 2 all squared, minus 7 over 2 all squared, then plus the constant 12. Remember, this is minus, that's why in the bracket all should be minus. This minus is what is in the formula, and it stays, it does not change. Compute 7 over 2 all squared. That gives you 49 over 4. So we have negative 49 over 4 plus 12. Compute that separately. That will give you negative 1 over 4. So you replace negative 49 over 4 plus 12 with negative 1 over 4. And that completes the square as x minus 7 over 2 all squared minus 1 over 4. If you want to find the values of a and b, you can see, because this one says plus a, therefore you must code the a with the sign. So a will be negative 7 over 2. The same, because it says plus b, you code the b value with the sign negative 1 over 4. So a is negative 7 over 2 and b is negative 1 over 4. Now, how do we work out the minimum point of a quadratic function using computing the square? We start by just computing the square of the expression x squared minus 6x plus 1. B is 6, so you divide it by 2, 3. So you slot 3 into the formula. But like I said, you should now be familiarized with your formula, and you should be able to substitute straight away. Now, 3 squared, you compute 3 squared. So you have x minus 3 all squared minus 9 plus 1. Compute negative 9 plus 1. That gives you negative 8, and that completes the square. Now, to get the minimum point, you need the x coordinate and the y coordinate. The x coordinate is always the opposite of the number in the bracket. It's always the opposite. So you have negative 3, so the x coordinate will be positive 3. But the y coordinate is exactly what is outside the bracket, which is negative 8. So remember, the x coordinate is always the opposite of the number in the bracket. So minus 3, the opposite will be positive 3. And the y coordinate is exactly what is outside the bracket, which is negative 8. So minimum point will be 3, negative 8. The coordinate is 3, negative 8. Let's try the second question. B is 4, so divide b by 2. 4 divided by 2 will give you 2. And you substitute 2 into the formula. That's what you have. 2 squared is 4. So next step, you're going to have negative 4 plus 7 outside the bracket. And we need to compute negative 4 plus 7, which gives us positive 3. Like I said, the coordinate point will be the opposite of what is in the bracket. We have plus 2. So the x coordinate will be negative 2. And the y coordinate will be positive 3. And that brings us to the end of our first lesson on computing the square. I hope you've enjoyed it. Please do subscribe and share with your friends. Watch out for lesson 2, which will be talking about computing the square for quadratic expressions where the coefficient of x squared is more than 1. More than 1. That will be lesson 2. Thank you very much.